So this whole front page is basically just a reference sheet of everything that we can use in our proofs so far, and that are referring to not only angles but everything else. So if you look at that first little box, the properties of equality, we've talked about all of these. We've used all of these. You have your addition property, your subtraction property, multiplication, division, distributive, substitution, reflexive, symmetric, and transitive. Those are all of your properties of equality that we can use for reasons in a proof. And then you have your properties of congruence. You have your reflexive property, your symmetric property, and your transitive property. Those are the only three that can be used with congruence. Otherwise, if we don't have one of those, we'll have to go to equality to be able to use all of the other ones. So then, just like we had with our segments, we have our definition of congruent, except for this time it's talking about angles. So if you will look right here to the left, to the right of definition of congruence, if you have something that says the measure of angle A equals the measure of angle B, then by the definition of congruence, you can also say that angle A is congruent to angle B. And you can interchange those backwards. If you're told that two angles are congruent, then you can also say that they are equal, their measures are equal, by the definition of congruence. If you are told that you have an angle bisector, then what you should be able to say is that an angle bisector divides, I want to change this, into two, not equal parts, but congruent angles. Okay, change those last two words for me, please. On that one for definition of angle bisector. An angle bisector divides an angle into two congruent angles. Okay, so change those last two words in that sentence from two equal parts to two congruent angles. So if in a proof I am told that I have an angle bisector, then what I should be able to do... No, I put this in the message if you don't know. If I'm told I have an angle bisector, then what I should be able to say after that statement in a proof is that I have two congruent angles. And that's the definition of angle bisector. If I know that I have two complementary angles, then I should be able to say that their sum is 90 degrees. The measure of this angle plus the measure of angle of that angle equals 90 degrees. Okay, so if you're told that two angles are complementary, the next thing you should be able to say is what two angles add up to equal 90. Same thing with supplementary. If you are told that two angles are supplementary, then you should be able to say, all right, well, angle A plus angle B, or the measure of angle A plus the measure of angle B is equal to 180 degrees. These are all reasons that we can use in a proof, and it kind of gives us what the statements should be. The next one is if you are told that you have two perpendicular lines, then you should be able to name some right angles. Okay, you should be able to name whatever angles are right angles. And if you are told that you have a right angle, then you should be able to say that that angle's measure is 90 degrees. Okay, so again, things that you could be told in a proof and where they would lead you to go after that. Okay, so again, if you're told that you have two congruent angles, you can say that their measures are equal. That is interchangeable. Definition of angle bisector. If you are told that you have an angle bisector, you should be able to state two congruent angles. If you are told that two angles are complementary, you should say that those two angles, the measure of them would add to be 90. The same thing with supplementary, except for it's 180. If you are told you have perpendicular lines, you should be able to name some right angles. And if you were told you have right angles, you should be able to say that those angles measure 90 degrees. So far, so good? Okay. Then we have some postulates and theorems. We've already talked about the angle addition postulate, just like the segment addition postulate. The angle addition says I can take one small angle, and I can add a second one, and they give me a bigger angle. Okay? Then you have the vertical angle theorem. If you know that two angles are vertical, then you should be able to say that they are congruent because of the vertical angle theorem. Okay, the complement theorem says if two angles form a right angle, then they are complementary. Okay, what do we know about complementary? We said right above this that they add up to be 90, so that's where that would lead us. You have the supplement theorem. You said if two angles form a linear pair, then they are supplementary, which means they add up to be 180 degrees. Another thing we can use in a proof. Everybody okay with that so far? I'm going to have to explain these next two, I think, a little bit more. Now, the next one is called the congruent complements theorem. The congruent complement theorem. And it says if angle A is complementary to angle B, and C is also complementary to B. So let me just draw you a for example. I'm going to do it down here at the bottom. So if I have the measure or angle A here, okay, and then I have angle B, and then I have angle C. So let's say that angle A is 50 degrees. In order for it to be complementary to B, what would B have to be? What plus 50 equals 90? 40. Okay, so B would have to be. So what this says is if angles A and angle B are complementary, they add up to be 90. And then it also says that angle B and angle C are complementary. Okay, so if I'm not looking at A anymore and I'm looking at C, if I know it adds with B to give me 90, what would C have to be? Okay. What this is saying is that angle A and angle C have to be congruent. If they are complementary to the same angle, then they have to be congruent. And the congruent supplement says the same thing, except for they're talking about they add up to be 180 versus 90. So if A is supplementary to B, and C is also supplementary to B, then we should be able to say that A and C are congruent. So you might be flipping back over to this when we start to look at our proofs. Okay, these are all things that we can use in our proofs as our reasons and also to guide us in our statements. Everybody okay with that first step we just went over? All right, let's flip it over. I really wish I had given myself a little bit more room here, but we'll make it work. All right, so we are looking at our picture. How many angles technically do I have in that picture? How many small angles do you have? You have 3 of them, right? You have angle ABD, angle DBE, and angle EBC. Can everybody see the little right angle markings there? There are 2 of them. It has that angle ABE is a right angle, okay, the one that's kind of tilted like this. And then DBC is also a right angle. So what we are trying to prove is that angle ABD is congruent to angle EBC. Now in a proof, what is our first statement and reason always given? So let's go ahead and set that up. Angle ABE and angle DBC are right angles. That's just me trying to abbreviate a little bit because I didn't give myself a lot of space to write on here. Okay, angle ABE and angle DBC are right angles. Okay, so what I want you to flip over on your paper and look at one of the things that told us about right angles. If I know that I have right angles, what should I be able to say about those angles? Look at the last one in the top part. Definition of a right angle. What should you be able to say? That they're both 90 degrees, okay? So that's going to be my first thing. Because angle ABE and angle DBC are right angles, that's what I'm told. The next thing I'm going to do is I'm going to say that the measure of angle ABE equals 90. And also the same one for the other one, the measure of angle DBC is also equal to 90. Oops, that's supposed to be a 2. And what reason did that say in the bold on the left side of that? Definition of a right angle. Okay, so that's going to be my reason. Definition of a right angle. Was I given anything else? No. Now keep in mind what we're trying to prove. I'm going to highlight what we're trying to prove. We're trying to prove that angle ABD is congruent to angle EBC. Now let me ask you this. I do know that they are both equal to 90, so I could say that they are equal to each other, couldn't I? Could I go ahead and say that the measure of angle ABE is equal to the measure of angle DBC? Okay, so let's do that. They both equal 90, so why not say they equal each other? And that is just either transitive or substitution. I would take either reason for that one. Because they both equal 90, then they can equal each other. Do I have any mention of angle ABD or EBC yet in my statements? No. Okay. So I've got to figure out how I'm going to bring those two angles in. So this is what I want to know. Let me do some erasing. If I'm looking at my picture, if I'm looking at just first angle ABE, is that made up of two smaller angles? Yeah. Let's say that then. Let's say what makes up angle ABE. The measure of, what's the first, the top angle? AB what? The measure of angle ABD, yep. Plus, what's that middle angle? DBE. Equals the measure of the big one, angle ABE. I'm running out of room, sorry. I have to remember next time to give myself more room. Does that make a little bit of sense? Okay. Now, we have one more reason that we're going to, or one more part of this statement. But how do I know that I can add two angles together to equal a bigger angle? Okay, I'm not adding the same thing to both sides. But there is a postulate on the front of our page that says if I take two small angles and add them together, I can have an equal a bigger one. What is that called? Angle addition postulate, yes. Which is different than the addition property, because the addition property says I add the same thing to both sides of an equation. Now, I haven't finished with this piece yet. Look at the other angle, DBC, that we are talking about. That was in my equation up here. Do I have two angles that add up to equal that one? What two angles are those? The measure of angle DBE plus the measure of angle EBC equals the measure of angle DBC. And that's the same reason, angle addition postulate. Is everybody okay with that so far? Okay. Now, it looks really confusing because you got a lot of letters going on, because that's how we have to name angles, with 3 letters. But just keep in mind that we're still just talking about angles. I'm going to kind of skip over some space so I can keep writing. So let me ask you this. What else did we say? We said ABE was also equal to what two angles added together? So I'm going to take out of step 3. Okay, I'm taking out that angle ABE and I'm replacing it with that longer piece. So the two yellow highlighted parts, I'm taking the small one and I'm replacing it with the bigger one. So I'm going to say, nope. I'm going to say the measure of angle ABD plus the measure of angle DBE is equal to, and I'm going to run out of room for this one too, so let me do something. I'm going to make my line a little curvy. All right, and then let's look at the blue highlighted. I told you that DBC was also equal to, what two angles equal together? So I'm taking the blue, the little blue, the DBC, and I'm replacing it with the big blue, the measure of angle DBE plus the measure of angle EBC, if I could write those. Kind of small there, sorry. And what says I can take something and replace it with something else? Substitution. Okay, now looking at that very long thing, keep in mind I'm trying to get to the fact that ABD is congruent to EBC. Do we now have ABD and EBC in the statement? Yes. What do you notice that's the same on both sides? DBE. So isn't there a property that says I can subtract the same thing off of both sides? Okay. So if I were to take away that DBE on both of those, okay, I'm not going to actually keep it crossed out like that. But if I were to subtract the measure of angle DBE from either side, what would I have left over? I would have the measure of angle ABD equal to what other angle? The measure of angle EBC. And how did we get there? What did we do to both sides? Subtracted. Is that starting to look a little bit more like what we're trying to prove? Is it exactly what we're trying to prove? No. What I'm trying to prove is that those two are congruent. If I know that they are equal, can I turn around and say they are congruent? Yes. And the reason would be? What's the very first one of the definitions that we talked about? Definition of congruent. Yes. Now, if I were to give you a proof like this on your test, I would definitely not expect you to do it all by yourself. What I probably would do would give you all the statements and just have you fill in your reasons. Does that make sense? Okay. Because this is a harder proof to do all by yourself. But if I gave you each statement, do you think you could fill in the reasons? Do you think you could kind of follow from step to step to step to fill in the reasons? Is everybody okay with that one? And not all of these proofs are going to be this long. But if I were to give you a long proof like this on the test, I wouldn't expect you to do it by yourself. I would give you the statements and have you fill in the reasons, or I would do the whole thing and just like leave some empty spots and have you fill those in. Is everybody okay with that? Because I'm about to erase it. All right. All right, let's take a look at the next one. Okay, go ahead and set it up. We know that our first statement is supposed to be our given, so we need to go ahead and write all that down. Okay, it tells me that angle 1 and angle 3 are supplementary. That is my given information. And yes, I will give you enough room on your test to be able to write all this instead of cramming it. And I'm going to abbreviate too, because okay. So flip back over. If we are told something is supplementary, what should we be able to say about it?
So
they add to equal 180. So guess what we need to say about angle 1 and angle 3? Based off of what we were given. So what we're going to say next is we're going to say that the measure of angle 1 plus the measure of angle 3 equals 180. What reason do you think that would be? The definition of supplementary. Now, do I know that angle 1 is equal to something else or angle 3 equals something else at this moment? What I'm trying to prove is that 2 and 3 are congruent. So let me ask you a question. If I've gone as far as I can with what I'm given. I was told they're supplementary, so then I told you that they added to equal 180. That's about as far as I can take that. So look at your picture. Is there something else you can tell me about angle 1 and another angle? What are the only other angles labeled in that picture? Angle 1, angle 3, and angle 2. Okay, so look at your picture. Can you tell me something about maybe angle 1 and angle 2? They're right next to each other. What about angle 1 and angle 2? They're right next to each other. What do they form? 180. A 180 because they're what kind of angles? A linear pair. So, if we look back at the front of our, let me see, somewhere it says something about a linear pair. Oh yeah, the supplementary, supplementary. If two angles form a linear pair, then they are supplementary, correct? So, what I can do is I can say, I can say that angle 1 and angle 2 are supplementary. And that's because they are a what? What do we call them? Linear pair. And then much like we did with 1 and 3, if I say that angle 1 and angle 2 are supplementary, what should I be able to say they add to equal? And that's the definition of, again, we already used it in step 2. So if I know that 1 plus 3 equals 180 and 1 plus 2 equals 180, should I be able to say that 1 plus 2 equals 1 plus 3? If they're both equal to 180? Okay. And that, again, could either be called substitution or transitive, whichever one you prefer on that. Where are we trying to get? What are we trying to prove? 2 and 3 are congruent. Do I now have an equation where 2 is on one side and 3 is on the other side? Yep. What's the same on both sides, on either side of that equation? 1. So just like we did before, is it okay if I subtract the same things off of both sides? Yep. So I'm going to say the measure of angle 2 equals the measure of angle 3 because of the subtraction property. And I'm trying to prove they're congruent. If I know they're equal, can I turn around and say they're congruent? Yes. And that is the definition of congruent. Okay, so very similar to the other one, except for this one we were talking about supplementary versus angle addition. Again, if I were to give you a proof that long on the quiz or test, I would give you the statements and have you fill in the reasons. Okay, I wouldn't make you do it all by yourself. Are we kind of okay with that? So, maybe, not really. All right, let's take a look at the third one here. This one's not quite as long. Go ahead and set up your statements and your reasons. We already know what the first one is. I am told that angle 1 is congruent to angle 2. What I'm trying to get to is that angle 3 is congruent to angle 4. Am I given any values anywhere in this problem? Like told that anything supplementary, complementary, 90 degrees, anything like that? No. So I don't need to go to an equality because I don't have any values given to me anywhere. And knowing that two angles are congruent doesn't really lead us to say anything else. So what I want you to do is I want you to look at your picture. Can you look at that picture and tell me any other angles are congruent? Zion, you're shaking your head. Yes, which ones? No. Mariah, do you have an idea? Okay, think back to your homework. We dealt with a whole bunch of what kind of angles where we set them equal to each other. Vertical. Do we have some vertical angles in this picture? Okay. Give me a pair of vertical angles. 1 and 3, you said? Yeah. Okay, angle 1 and angle 3 are congruent because they're vertical, right? What other pair are congruent because they're vertical? Mm-hmm. So what I can do is just by looking at my picture, I can say that angle 1 is congruent to angle 3. And angle 2 is congruent to angle 4. Because what is that thing say right under the first theorem? If two angles are vertical and they are congruent, what's that called? Look under where it says theorems, the very first one. Vertical angle theorem. Or you can just say vertical angles are congruent. We'll go vertical angles, or not angles, vertical angle theorem. Okay, and I'm abbreviating. Vertical angle theorem. Okay, or you could just say that vertical angles are congruent. Now we have to be careful because we're dealing with congruence here. So we're going to break this down into a couple of different pieces. If 1 is congruent to 2 and 1 is also congruent to 3, what two angles could I say are congruent because of the transitive property? Mm-hmm. I keep writing the wrong number. Is that what I'm trying to prove, though? No. Okay, so let's look at the other piece of step 2. If 2 is congruent to 4 and 2 is also congruent to 3 by the transitive property again, what can we say? Angle 4 is congruent to angle 3. And again, that is the transitive property. Does that look exactly like what we said it's supposed to? It's not really, right? It kind of is, but it's just in the wrong order. Is there a property that says we can just switch that around? Symmetric property. Okay, so that one wasn't too terrible. You just have to break it down into pieces. And you also have to know where you're going and get used to being able to do these angle proofs. What I do want you to try to do is in that last proof, I did give you the statements. I want you to see if you can fill in the reasons for me. Okay, on that last proof, I gave you, you have the picture above. I gave you each statement. What I want you to try to do is fill in the reasons. This is more like what I would ask you to do on a test on one of the more complicated proofs. Again, I give you the statements. It says angle 4 is congruent to angle 7, and that reason is because it's given. And then it says that angle 5 is congruent to angle 4, and angle 7 is congruent to angle 6. Look at your picture and decide why that is true. Okay. Look at your picture. Look at angle 5 and 4. Look at 7 and 6. Why would we be able to say that they are congruent? What kind of angles they are? angles of 5 and 4.
And then again 6 and 7.
They are vertical angles. So what theorem says vertical angles are congruent? Vertical angle theorem. Okay, so that should be my reason for statement number 2. Vertical angle theorem. All right, and then let's look at this, okay? If 4 is congruent to 7 and 5 is also congruent to 4, then 5 is congruent to 7 by what property? Five is congruent to 4, 4 is congruent to 7, 5 and 7 are congruent because of the, what'd you say? Transitive, yeah. The transitive property. And then if, let me see, 5 is congruent to 7 and 7 is congruent to 6, then 5 is congruent to 6 for what reason again? Transitive.